Let's get going. And expand that ever so slightly. We have put in our packages that we had before. We have put in our data that we had before, quite a bit of data. Let me actually move this out of the way. We don't need to see that. This is the hurricane data where we decided to focus on things that were only between 1960 to 2020. And we decided where historic versus recent data were. And I literally don't remember off the top of my head. So let's find recent. Recent was defined as 1986. And if I remember correctly, it was a few years after the inflection point, or was it the inflection point in terms of global climate change? Okay, so it's right approximately where the inflection point is, where we start to see global increases with the idea that climate change could be influencing some factor of hurricanes. Great. We took out some of the variables that were not necessary. And someone remind me why we've removed death and monetary damage. Thank you, Gabrielle. I saw your hand. That was very nice of you. Why did we remove those two variables? Yeah, more or less. They were more about the economics of the hurricanes, which is a great question to address, versus the climate change potential of the hurricanes. That makes sense? And since we're not going to be dealing with economic issues associated with the hurricanes, we just dropped them. And how we drop them, we just put the minus sign in front of the variable name. You could do it proactively by adding in things, but then you would have to put them all. Why did we decide to go with this approach? Saves us time. It's the big L. It's lazy. It's good. Again, I like to be efficient and I like to let other things do the work. There's a lot of hard work. For this homework assignment I gave you on Tuesday, the hard work is figuring out mu. That is a lot of work. And then also to figure out whether these are parametric or non-parametric approaches would be appropriate. That actually takes thinking. The stuff that I could do easily without thought, I don't want to spend my time thinking about, because I got to spend it and put in the energy to think about those other pieces. We mutate time, so time is factor, and we have two periods in time. By the way, is that categorical or continuous? Time, recent, and historic. Categorical, is it nominal or is it ordinal? Nominal or ordinal? Or ordinal? Which one is it? It's ordinal. How is it ordinal? Remember, this has a structure, numeric structure to it. Historic is further in the past. That's a numeric structure. Recent is closer to our immediate past. That is a numeric structure. That is ordinal. So we run our piping, we run our tidyverse, we get our summary. We now have a new data set. We've lost a few variables. That's great. We look over here in our environment. We can see we have factors, two of them, historic and recent. So we're in good shape. We run our summary, and I like this as well. And I like this as my biggest check. I like to just make sure that my factors are actually showing up as factors. I get counts. How many times does something occur? I got a count. And 26 times per historic, 35 times per recent. Should we be panicked that they're not exactly the same? No. No, every once in a while, you'll get a statistician, like, you have to have even sample sizes. And you would respond back, but I'm a biologist. And that's what the scientists tell me. So we'll get over it. We're going to use these sample sizes, right? Good. Okay, excellent. Don't talk to your family statistician that way. That's just not very nice, is it? All right, so we put in our question. Has the number of major hurricanes changed since the inflection of global temperature increases as a result of climate change? Why was it important to write this in our script? When did we come up with that question? Yes, to see what you're trying to answer. When did we come up with that question? That question, right here on line 20. That question. When did we come up with it? When? Yeah, when did we come up with this? When did we discover this? When did we come up with this idea? We got this idea. Tuesday. Tuesday. And what is today? Thursday. And how many of you had a perfect memory of exactly what we came up with on Tuesday? Oh, hell no, I did not. I had no bloody clue. I was just sort of fishing around thinking I did have some sense of what we were doing, but I didn't. Came off very nicely, but I could read our writing, and our writing's pretty clear, and that helps. So always give yourself those notes. Remember, your past you is a punk. That individual hates you. That individual hates you because that individual does not give you enough information. Do not let your past you rule your present identity. Trick your past you by always giving yourself information that your present you can deal with. I like that question. That's a very good question. And now we have our t-test. This is where we ended up. Why do I cackle a bit? Chandler, you're actually my first up today, mainly because I cannot sort my screen and you were the last person on Tuesday. So today you get to be the first one. Why did I cackle when we produced this 2-sample test? What do we start with always? First thing you always start with. When you look at your results, you always start with this, the p-value. Do we ever end with a p-value? Never. We start with a p-value. We always start with a p-value. Yeah. So we know we have a t-stat. That's cool. Our t-stat is negative. Does it matter that it's negative? No. We just take the absolute sign of a t-value, report that. We have our degrees of freedom. That's weird. We'll talk about that in a little bit. And then we have our p-value, and I cackle. Shannon, why did we cackle? And what is so important about 0.05? The type 1 error, the degree, the probability that you would be making a mistake by accidentally rejecting a true null hypothesis. And what do we describe if the number is below 0.05? Typically. When the number is below 0.05, what do we describe? We describe the alternative. And what do we describe when the number is above 0.05? Describe the null. And what do we describe when the number is basically 0.05? That's the reason for the cackle. Okay, if you are an absolutist, you should describe it as the null hypothesis. But that's ridiculous. If you are squirmish and all you want is significance, then you describe it as there is a pattern, because you can round that kind of down and say it really does look like 0.05, and therefore we have significance. That's ridiculous. Both of those are inappropriate. You've got to deal with the number as is. And the number as is suggesting something, but you don't have a definitive evidence. So the result sentence that I wrote is there may be a slight increase in the number of major hurricanes since 1985, because I looked at major hurricanes. You can look at whatever you want, although the change is not significant. That's probably was not significant. Oh no, it should be. It is not significant. So you're dealing with the fact that you're in a little confusing state. It's not completely definitive, but it's not definitive either way. It's not definitive to describe the alternative. It's not definitive to describe the null. They're kind of in between the two. For me, I'm somewhere around 0.03 to 0.09. That's where I'm a little squirrely on how I describe things. That's when I'm a little circumspect. And that's when I pay attention to sample size. If my sample size is enormous, my degrees of freedom are 10,000, then I have a lot of confidence that there's a threshold. And if I want to say there may be, it's going to be ridiculously weak. And I'll go into other things and look at that. If my sample size is pretty small, and it's a pretty small sample size, then I may be more inclined to think that we have something that's going in a direction but not present there. Now, can someone give me a strategy and this wasn't anyone, of what's a way to sort of explore further into this data to figure out whether this is an anomaly or actually just maybe a weak indicator of an overall pattern. And you have the data. I do like the lack of eye contact. A lot of people are looking deeply at the screen. That's good. Every once in a while, kind of like a little rabbit, I get a few eyes that look over me, quickly look away if I look in that direction. But where would you have more confidence? Let's walk through this. We looked at major hurricanes. Major hurricanes are going to be the most rare event. Why are they the most rare event? One, they require a lot of energy. Two, all major hurricanes were tropical storms. All major hurricanes were hurricanes. Therefore, tropical storms should be the highest occurrence no matter what, followed by hurricanes, followed by major hurricanes. So major hurricanes are the rarest event. So you might expect the least amount of variation in there. And statistics compare central tendencies relative to variation. And therefore, discriminating that variation can sometimes be difficult when your samples are very small, or the number of occurrences within a sample is very small. That's variation. What about if we looked at hurricanes and we saw that hurricanes has a very small p-value? Would that lend support or distract from suggesting that maybe there is something going on with major hurricanes? It would be consistent with the idea that there may be something going on with major hurricanes. Let's say we look at both tropical storms, hurricanes, both of these have very tiny p-values, so we describe the alternative. And now we go back and we look at this p-value of 0.05. I wouldn't change my sentence at all. Or maybe a slight increase, but it's not significant. I'll keep that sentence. But in a discussion, I might actually describe the fact that there's clear evidence that both tropical storms and hurricanes appear to be increasing. And there's some evidence that suggests that maybe major hurricanes are as well. That's a discussion point. You put it into other things. Let's say you look at hurricanes, tropical storms, and cumulative energy. And all three of these have very tiny p-values. What do you feel about major hurricanes now and that weird little cackly p-value? It's probably describing a pattern. There's probably a pattern going on. There's probably a pattern consistent with the other measurements. Now let's go back. We see something here that's squirrely. We look at hurricanes, it's a large p-value. What does that kind of suggest about here? Maybe it's the null. We look at major hurricanes. We then look at hurricanes and we look at tropical storms, and both tropical storms and hurricanes have large p-values. What do we now think about this one? It's probably the null. There's probably something weird going on. We look at cumulative energy, hurricanes, tropical storms, all of them are saying high p-values. We still got this one. That's honest. That's accurate. You got to report it. I wouldn't change my sentence, but what would I be talking about in my discussion? Don't show a pattern. Although we may have a signal with major hurricanes, it's unclear whether this is associated with the time periods being evaluated. So a lot of times, even when we get one measurement that says something that's a little difficult to deal with, we can use other measurements, other analyses to help us infer what we should deal with that one that's right on this threshold. You remember before, what did I say about using the minus sign when we did select? Why do we do it? Makes our life easier. And what did I say I want us to spend our time doing? I want us to think. This is fun. It's annoying as hell, but it's fun because then you get to think. Did anyone do hurricanes? Anyone do energy? Anyone do tropical storm? What'd you get? Give me a p-value. 0.052, right? So 0.052 instead of 0.055. That's awesome. Okay. So what about that p-value? Just for everyone else, p-value is 0.052, 0.053. Does that help us or does that make it more confusing? Kind of makes it more confusing. Awesome. Awesome. Dave would do hurricanes. Oh, I'm going to get some of you. That was perfect. 0.053. 0.06. Great. So what does that suggest? Is it helping us at all? Not at all. Not at all. Making our life real miserable. And what about tropical storms? What do you get? So tropical storms says, damn, what are we supposed to do with our null hypothesis according to tropical storms? What do we do with our null according to tropical storms? We reject our null. If we reject our null, what do we describe? Alternative. Are you now completely confident that all these patterns really are the alternative? Good answer. I would be very squirrely about that. There's a very small p-value for tropical storms, and do it on your machine. Very small p-value for there. There does appear to be a pattern there. Hurricanes, weird signal, 0.06. Major hurricanes, weird signal, 0.00 or 0.55. Or energy, weird signal, 0.053. I think the cumulative for that one, I would be left saying, more work is needed. Questions with that? Yeah, well, let's do them. Let's not repeat them. Let's do them. So for that, collect your copy, paste. Let's make that one hurricanes. We get that. I'm a little bit higher than what I heard, 0.07. Let's do tropical storms, as we were told, very tiny p-value, less than 0.001. Then energy, kind of annoying. Yeah, so it's great. So these are codes. I didn't put attach because I didn't run through attach. You'd have to put a df in the tab t apply line in front of each of the variables, but those are the codes, all three of them. That was a much more interesting story than I expected. Cool. That made me happy. Questions with this? Questions with strategies about how to think through things. Yep. So in that, and I'm going to scroll up here for the result sentence. So I'm going to scroll up for a second. I would not change the result sentence for anything that comes out from the other signals, because the result sentence is the description of the pattern. And the description of the pattern is there may be a slight increase. We saw 2.85 major hurricanes after 1984, and we saw 2 major hurricanes on average before 1984. There may be a slight increase, but in the methods, I would have put down an alpha value of 0.05, and therefore I would add a statement of, although this is not a significant pattern. And I would use the word significant, even though normally I don't like it. So the result would not change at all. What we were talking about is then what do we do with all of these results in terms of talking through the discussion? If there are clear signals, then I think you have confidence in your discussion to describe an overall pattern, one way or the other. We did not have clear signals whatsoever. And we had very murky signals, with one of them being pretty clear. I would have to think for a while about what to do with my discussion with that. Do you have to write discussions in this class? Nah. No, we are all about results. Questions with that? Okay, so let's save. Let's do a nice little exercise we've done before. I want you to take your variable of interest. You don't have to do all four of them. Take one. I want you to take your variable of interest. I want you to plot it. Plot like we plot before. This will be the last time we do that ever. Where we're going up into the major leagues in about 10 minutes. Plot like you did before. Please write a result sentence, an appropriate result sentence for whichever variable you did, and put it as the main above your figure. Any questions? All right, let's get. If you're okay, I heard a request for Taylor Swift earlier today.
I wouldn't do that. And run it.
So whenever I was originally entering my data, I messed something up because the two values are completely different from yours. And I think that, like, I just wanted to ask because I was looking and I was like, oh, I see that I have stuff like them.
They should have had an effect. Let's go to the top.
But I wasn't.
It goes all the way. And up. Up. Okay, so start 60, go down.
That's what I like that.
Keep going.
I shifted like in the Excel file, I accidentally like moved something over before, but I thought that my fix was fine. But I think it's as soon as I get to like, I don't know.
Okay, so one of the things I do when I get this is I'll go into Excel and I'll go to my last row and I'll go all the way to the expansion. So I'll shift and then I'll hold the down arrow and
with the hands, so you just go all the way to that, not to leave every breath. That gets rid of those, but I'm not sure why you got that. It's a little weird.
Yeah, it was my shoulder, for some reason they were. But for this is the thing that I named the piece, the hurricane, it's this.
It's very close.
I don't know.
It's close.
But yeah.
Okay, okay. Yep. One more time. No, I don't know. Yes. Oh, because I didn't put it attached because I didn't put the variables in the ignore. So I had it for, yeah.
Oh yeah, just so you guys know, there's a good chance when I put this up on YouTube, it's not going to be allowed because I forgot to cut out and pause the music. Ms. Swift will get mad at us. All right, so we'll see what happens. Low code, just as a reminder, sometimes if you don't do attach, you have to put it in the matrix. DF. Put it attach, you don't have to do that. When you're dealing with multiple data frames, you want to get into that habit. For the most part in class, we won't. But I forgot to, so I had to put DF $, and I was too lazy to go back up into my script to actually do attach. So do F $. Main, it's our figure legend. I took the exact same sentence as before because that is an appropriate result sentence. There may be a pattern, but it's not significant. We chose a particular threshold, and whatever we want to do, the number is above the threshold. These /ends, that creates line breaks. It's not the only way to do line breaks, but it is the most controlled way to do line breaks. And we'll see what that means later. When you write your results, you always provide your evidence. And remember, the p-value is where we start, but it's not where we end. We have to provide both the t-value and the degrees of freedom. And this is a weird degree of freedom. This is when you assume there are unequal variances. And part of that is you cheat some of your degrees of freedom and use that to allow you to do the stats. And what would we describe? We say there might be a change. We would describe that there might be an increase. But again, I keep saying the word might. P-values right at that threshold. Nothing definitive, nothing strong. Make sense? Is this good? You happy with this? Okay, we're never making a figure like this again. This is ugly. You make a figure like this, you put it up somewhere, people are like, oh man, that man's not hip. That lady's behind. No, we're going to be converting over to something called ggplot. ggplot is a grammatical language for graphical elements. And it is the standard format by which things are presented. There are a variety of reasons why we use it and why we like it. And we had discussed, Sean and I, this past week, whether it was time to bring you in. And I had planned to wait about 3 weeks. Sean made a good argument. This is what we're going to be doing, and this is what you're going to want to do afterwards, so there's no point of waiting. Let's just get right into it, and let's start doing it. Initially, it will look cumbersome. As soon as you get used to it, and as soon as you get used to how to work with the logic of it, it is very nice and powerful. Most importantly, it allows you an incredible amount of visual control. And as important as the mathematics are in terms of statistical communication, so are the figures. The figures are absolutely key to helping other people understand what you are describing. One of the nice things about Tidyverse is Tidyverse includes about 100 different packages. One of the most important ones that just come with Tidyverse is ggplot2. So anytime you upload Tidyverse, anytime you include it as a package in R, that will include ggplot2. Does that make sense? With ggplot2, we're going to be doing 2 steps, and always a minimum of 2 steps. The first thing we're going to do is something called defining the aesthetics. The aesthetics are sort of the bound parameters of our visualization. In this case, what is our x-axis? What is our y-axis? Do we have any variable that will color differently depending on a category or depending on a data point? We define the aesthetics. Do we want a degree of transparency so that you can actually see a little bit behind? This actually becomes valuable if you want to show actual data points. We define the aesthetics. And what data are we taking this from? What data frame are we going to be using? For us, for the most part, it's always the F. So the first thing we do is we've defined the aesthetics. The aesthetics we then apply to any type of visualization that we want. We're going to be doing a box plot. So we're going to apply the aesthetics to a box plot parameter. We're going to create that. Then may want to add labels. We could do that. We may want to add lines. We could do that. We may want to add any variety of things, Cartesian points, legend, all these elements. We do those. We may want to define the width and the length of the data points. We may want to jitter the data points so they don't overlap each other. All these are just different parts of a grammar, much like the way we write sentences together to compose a paragraph. That's how ggplot operates. This makes sense? The one new character we'll be using a lot is the plus symbol. You write a sentence, we're in a normal sentence, what do we use to end it? Period. What we do in ggplot to add another sentence? Plus. When we are done adding sentences, what do we do at the last element? Nothing. That's it. Does that make sense? So, let's see if we do this. All right, well, I gave you too much. The first thing we need to do is create a plot. What we want to do, and change it to 2 sample. I'm smoking something. We're going to create a variable. A variable is 2 sample that is going to define the parameters of our aesthetic. We're going to make it a ggplot. That is a function, and then we put it in parentheses. We have to define our aesthetics, that's AES, aesthetics, and we define what the X variable is. Now, when we wrote up these notes, we made it into time. That's no longer, I think, what we have. Or do we have time? What is the variable for recent and historic? The variable name? Great, look at that, fantastic. Then we have the y-axis, and the y-axis has to be one of our 4. It's not frequency. It has to be tropical storms, hurricanes, major hurricanes, or energy. It has to be one of those 4. You choose yours. Fill is how it gets colored. You can define the colors exactly the way you want. And when I say you can define the colors, this is when you can really get into colors. What's your favorite? You like the Wes Anderson. I thought you also liked Brewer for a while. Yeah, and I like the colorblind. You know, they're different palettes that allow for different types of visualization. And literally, I like colorblind because you have a percentage of people in your audience that are always colorblind. So why put up anything if I'm giving a talk? Put up colorblind, and then it's not a problem for those individuals. And you define your data frame. You guys should be writing this. And you should also be translating it. Once you get to here, go ahead and stop, and at that point, we'll go through the next step. Fabiola, what's going to happen when I hit run? Great, let's find out. So we run it. What happened to me? I got a bunch of errors. What should I be looking for, and how should I be looking at those errors to see if I can figure out what's going on? Victoria? Target sign, non-language, and it localizes where you might have an issue. So it's not showing me all of the code, it's just actually showing me the aesthetics. There's some problem in the aesthetics. I look across, ggplot looks correct, AES for aesthetics looks correct. Time, I could go over and check my environment. Yeah, time's correct, that's good. I keep going across, major hurricanes. Major hurricanes, Jordan actually caught this. So very nicely done. Dumb no typos, small no typos. Can be really maddening because it doesn't work. So I'm gonna clear out that. I can clear out that, let's try again. There we go. Oh, come on. What now? Oh, there it is. You're welcome. So is it the dash that you all had the problem with? Or the two? The two and the dash. So yes. Yes, make sure you guys put that down in your evaluation because it gets shared with the provost and the president. He's an idiot. And let me give you examples. Yep. And we didn't even get into major hurricanes, but still, Jordan caught that very well done. R can only read some things, can read other things. Change it into words, we're fine. 2_sample, we're good. Fabio, let's go back to my original question. We run this. What happened? Nothing happened. What we did is we created an aesthetic in our environment. So we're going to pull from that to actually create and make the figures. So I'm going to go back here. We're going to take these one at a time. What I'm going to do for this is I'm only going to copy and paste up through a plus, because each of these are elements. Each of these are sentence in the grammar of our plot. I'm going to fix my 1 dash and make it 2 sample. Write it in. Run lines 52 through 54. And then as you do, what I want you guys to do after that is I want you to define for 3 things. What is GM box plot? You probably don't need to do anything to figure it out, but define it. And I'd probably define it as a note up above. Outlier dot size equals -1. And for that, what you may want to do is rerun it and change the number, see what happens. And then alpha 0.7, same thing. You may want to change the number, see what happens. And then once you see what happens, I want you to define it. So Lauren, what is 2_sample? What is 2_sample? For that, you can look at lines 47 through 50. It's the aesthetics. Yep, it's the variables. It's how we're going to organize our variables. 2_sample is the aesthetics for the plot. We're going to have an x-axis for time. We're going to have a y-axis for major hurricanes. We're going to have a fill for time. So the x-axis will have colors associated with the different categories in that variable. Make sense? Now, I'm still going to come back to you, Lauren. What is geom box plot? The geometry of the plot we're going to use. So geom is actually referring to geometry. So what geometry are you going to use for your figure? And you're just telling them, we're going to use a box plot. And that's what ends up getting created. Connor, this may or may not have been visible. I actually don't know. But what do you think outlier dot size equals -1 do? Yep. Huge. And if it's -1, do you actually see the outliers? Nope. We don't see the outliers. We won't do this today, but later I'll show you guys how to put in the actual data points. So you're not actually representing just the outliers, you're representing all of your data points. Where are outliers going to be? Outliers are just easily defined as those things above and below the 1.5 interquartile range. So if they're above that, those are the statistical outliers. If they're not, they're just data points. But we want to put in the data points eventually, and that's what we show as part of our box plots. So in this case, we want outliers to equal -1, so we don't see the outliers yet. We'll put them in later. And then what does alpha do, Connor? Saturation transparency. So it's just saturation transparency. So the base box plot has historic, has recent, for me, major hurricanes, time. Now, some other people saw some weird stuff. Did everyone get this exact same figure if you did major hurricanes? Great. I got some, I have some, For the individuals that go, what'd you get? Okay. Well, yeah, well, that's cool. That's cool. So I can do this. Ooh, a rectangle. And you can actually define all those parameters later so you can make it standardized. But some people got some extra information. What did you get, Gabrielle? Got a column of NA and there's nothing there. There's an extra column. What's happening there is in the original Excel file, there's information in the data. It's not numbers. Has nothing to do with R. There's just information in that Excel file, like I transferred over to the CSV, and R doesn't know what to do with it. So it's just an extra column. How you fix that, not terrible, but it's a little cumbersome. Go back to the Excel file. Here's all of our stuff. I'm putting my freeze pane. I'm going to organize all my columns so they are standardized widths. And then I do two things. One, I go to my first empty column. I highlight the entire column, hold down Shift. For the max, I hold down Command, and I hit the right arrow. What that would do is highlight every single column that doesn't have any real information, numbers, letters. I right click it, I delete it. I go down to the bottom. I quickly go down to the bottom by holding my command key. If you're on a PC, hold the control. I hit the down arrow, that sends me down to the available area. I hold Shift, I hold the space bar. That highlights the entire row. But then the same thing, I hold Shift, I hold Command, I go down. I've now highlighted every single row. I delete it. I then save it again. And now when I import it, any extra information that was there is gone. So when you make that figure, you will actually just get the two columns. You'll get the issues without problem. You guys remember when I was talking about Word and Excel, they add extra stuff? If you got that weird column, you got extra stuff. Later in the semester, I'll teach you a way to do this in R. So you just get rid of all those NAs and you don't have to go through this laborious step. But this works. It works pretty well. So the next element. I'm putting a plus sign. And we have a next group. So we're adding a sentence. Let's add the following to that sentence. Same as before. First, identify what the geometry's doing. What's our geometry doing? After you get it working, figure out what PCH is doing. Change it. After you get it working, go to alpha. Change that. After you get it working, if you get really cheeky, figure out what's going on with shooter dodge. Shooter dodge height, shooter dodge width. Change those numbers.
Yeah. Errors in modify.
That was. Oh, no, this is show up in monkeys.
Say one.
Yeah.
If you're sorry, like.
So yours has that cell issue. So if you bring up the cell that you're at.
This part of it, where way down and we got ever and go back on it.
It's not. That you get from this.
Yeah.
One way down, one way down.
That's something I that myself.
I should do order.
Okay, so we did.
Again, make sure you put in some notes to define geom point. Make sure you put in some notes to define PCH. Figure out what PCH is by changing it. They would have to do the thing. Make sure you have some notes about jitter dodge. Change it, see what happens.
Yes. Yeah, yeah. That would be why the jitter is how for this way they are each other. You can get the jitter or jitter.
Yeah, I guess.
That's still there. Yeah, I mean, but now it's 89 instead of 111.
Yeah.
Better.
Sometimes you really just have to stop. And like, it's annoying, but like.
We require adding one element of those.
Okay, no, I don't know.
Maybe they're trying to come up with a little thing is.
Your data. Yeah.
So geom point. Gabrielle, what's geom point do? Geometry of your data points. So what I personally, this is a personal preference like about this, is not only do we show the box plots, but we actually show each of the individual data points. So what we're doing is not only showing the overall summary pattern with the medians, 25th, 75th percentile, the interquartile range, we're showing each individual data point there. The reason we get rid of outliers up here in 53 is because we're going to put them back in, but we're just going to put them back in as a data point. We're not going to separate them out to something that's distinctive. They're just part of our data. And then, Gabrielle, where's 22 do? 21, sorry. We put in something else. And actually, I've never done 42, and I don't think I'll do 42 again. That made that really smiley. We'll do 24. Triangles. I'm really saying triangle man. What's that? Oh. I'm going to keep it upside right triangles because that just got me scared about 40 or World War II. So I'm going to leave the triangles the way they are. Yeah. So each one of those gives you a different point character. That is what PCH stands for, point character. Each number defines a different point character. Identifying a point character is very easy. Just go on to Google, look up point characters in R, ggplot, and there'll just be a list of each number and what the actual corresponding is. You find what works for you. I personally use 23 for a very simple reason. I think circles are points more than other shapes, one. And not only does it give you a circle, but it gives you a darker outline, which makes it more distinctive, too. That's why I use that. You can pick what you want, or I'm sorry, what I use, 21. There we go. That's what I use. So Catherine. You got the hard one. What's going on there? Position. Okay, so let's start with that. Position of what? Of the points. Our G on points, so we're doing everything about points. So it's position of the points. We're doing position jitter dodge. I love that word, jitter dodge. What is jitter dodge? What does jitter mean? Jitter. Yeah, if you're gonna jitter, what are you gonna do? No, move around. We got jazz hands in the background as jitter. I was kind of thinking shaking convulsing as jitter, but jitter, you little move around, randomly. So we're gonna do a little moving around randomly. What are we gonna move around randomly? The data points. The data points have an exact value. The data points have an exact value, but we're gonna move around a little bit randomly. Okay? How are we gonna move them? We're gonna jitter them by the height. So we're gonna move them by the height. A little bit of jitter, a little bit up, a little bit down, randomly between that axis. Large amount or little amount? Little amount, 0.01. We're gonna move by the width, a little bit to the left and right, along the x-axis. A lot amount or a little amount, relative? More than. Jitter height, a little bit, jitter width, quite a bit. Now, before I show you, someone tell me why would we wanna do that? So they're not on top of each other. So if we hide these, and that's pretty easy to do, all we gotta do is put hashtags in front. It's still gonna work, right? We got a comma here, we got our next line here, so I can still run it. Everything is now on top of itself. It has an alpha, but all the data points are right on top of itself. Is it useful? Can we see how many times we had 0 major hurricanes, 1 major hurricane, 2 major hurricanes? So one of the reasons we use jitter dodge is when we have overlapping data points, maybe because there's a lot of them, or maybe because they are whole numbers. You can't have half a hurricane. On average, it can be a decimal, but you can't have half a hurricane in the year. It's going to be 1, 2, 3, 4, 20, 0, but some are going to be 1.5. So for any year, you may have a lot of years with 2 hurricanes, and you expect that considering these are medians. The only way that you can visualize that is if you move things. Not everyone likes this, and not everyone agrees with this, because you are literally repositioning the data points. And some scientists, what they do is they go into papers, they go into figures, and they pull out the data exactly as illustrated in the paper to create new data sets to do meta-analyses of larger questions. They need exact information. Jittering messes that up, but jittering also clarifies points tremendously. And who do I care about first? Do I care about my paper or what someone else might do with my paper? I care about your paper first. So you can mess these around if you want. You know, if we take away that 0 and make it 0.1, our jitters go a little bit more up and down. In this case, that actually may be appropriate. It may be good. It does move them up and down more, but considering these are whole numbers, you know, everything in this cluster is 3 hurricanes. Everything in this cluster is 2 hurricanes. It's not 1.9, 2.1. They're all 2. So you're kind of separating them out, moving a little bit to get to an aesthetic that actually works for you. Makes it a little bit wider. This is another one of those things where you decide. You sort of mess around with things to make a story that helps to explain your observation. Make sense? It's the last thing. Are y'all happy with this figure? Does it make you happy? You're like, yeah. There's no result sentence. What else kind of is weird? I mean, I know I talk fast, but I think even with my speech, I do have a pause between words. I mentioned hurricanes. If nothing else, it doesn't look right. Let's fix it. So When we are adding an element to a ggplot, what is the character we use to say there's going to be another sentence? We use applies. Okay, there's a little bonus now. How is it labs? Sean, the labs or lab? The labs or lab? That was lab. It's labs. All right. Don't put the equal sign after labs, but then you can define them all. Define X, put inside quotes. Define Y, put inside quotes. Define your title, put it inside quotes. And now we're actually going to add in your subtitle, put it as statistical evidence. The statistical evidence needs to be there, but it's not as important as your biological description. You have to have it because it's your justification for the description. Considering our hypothesis generated based on climate change, I'm going to put climate, recent, historic, not time. I want to again help the reader, the audience, have information that guides them through. For the y-axis, I'm going to put major hurricanes, but then I'm going to put per year. Again, I want to help the reader, the audience, have the context. For our Excel file, for our CSV, for our code, major hurricanes is more than enough. In fact, you could put down MH, make it really easy for yourself if you remember that. I like to word out the words, it makes it easier for me. But you can make your own choices there. But for your audience, you want to help them. And since I have major hurricanes as all caps, and I'm going to make a capital here, then I have my sentence. I'm going to steal my sentence from before. In there. Maybe I'll have a break here and a break here. And then last but not least, I'll give my statistical evidence. And then we run it. Oh, you mean down run the stats? You certainly can. And for that, you just put the parentheses inside the quotes. So it shows up in the figure. Very appropriate, very fine choice, probably more standard. Sean, should we talk about degrees of freedom today? Love that. That was pretty good that you threw your voice and you went female. That was awesome. I am impressed. All right, I'm going to save this. What I want you guys to know is a few things in terms of even the labels. There are more fields in which you can put in labels. One of the fields that I find particularly valuable is subtitle. The reason I find subtitle valuable is subtitle tends to be set off from the title. Automatically, it makes it a smaller font size so that you can draw the attention of people where you want them to go. Where you want them to go is your results. You need to have the evidence, so you're presenting it so that's justifiable. But what you want people to pay attention to is you want them to pay attention to your figure, and you want to pay attention to your description. Now, there's one last thing with this figure. Is there anything in this figure that is annoying today and it's redundant and should be gone? Silly. Connor? The legend. We'll get rid of that next time. The legend. It's unnecessary. We don't need it. Very easy to get rid of. Just another line. So that we actually have that element. And we don't need it because it's already here. It's right there. Make sense? Okay, I save this. I want to go back. Oh my gosh. Julie, you're not randomly up, but I'm still going to ask you anyways. Does that make sense? Degrees of freedom of 58.9. Is that how degrees of freedom normally look? Give me a typical degree of freedom. 3. Give me another typical degree of freedom. 7. Someone else give me a typical degree of freedom. 22. Love it. Another typical degree of freedom. 59. What are we noticing about all these examples, which are perfect examples? They're whole numbers. Degrees of freedom tend to be whole numbers. This one is not. We'll get to why this one is not in a second. I told you before, but I didn't give you any logic on it. I just said it. Let's go back a step. What's a degree of freedom? Does anyone know what a degree of freedom is? It's kind of a cool thing. I'll tell you what it indicates. Let's start with that. A degree of freedom tells you the approximate sample size that is related to the t-stat to get your p-value. So basically, it's an indicator of sample size, where changes in sample size influence how we should read and understand something like a t-stat, or an f-value, or a chi-square value. And both of those informing our p-value. For you, you can just look at the degree of freedom to see how many groups roughly are there. And we'll go into a little bit more detail. But what is a degree of freedom exactly? And there is no more R or computer today. What is a degree of freedom exactly? And what it means and what it describes is the number of data points that can vary with a known answer. It's the number of data points, samples, groups that can vary with a known answer. So I need a favorite number. I heard 7, 2, and I heard 42. I'm using 42. I like Hitchhiker's Guide to the Galaxy. That's our answer. Okay? We're going to sum up a series of numbers. How many numbers do you want to sum up? Okay. N equals 6. Connor doesn't get to play anymore. What's the first number? Come on, not hard. We're gonna add up. All we're doing is just summing. We're gonna add up 6 numbers, and they're gonna equal 42. What's the first number? No. 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 I don't know. You haven't told me yet. What's the first number? Jeffrey, what's first number? No. Diana? Amanda, you can play. You're online. Amanda, Emmanuel, Jamie, give me your numbers. Put them in there. Victoria? No. Jamie, it's not 7. Okay, Julie? No. Madison? Oh, come on. That was cheeky. I like to, just so you guys know in Zoomland, Madison walked out of the room when my head was turned. Very well played. Emmanuel, it is not 13. I like that number, not 13. Misty? What is this number? Absolutely. The sum of the 6 numbers is 42. A, B, C, D, E, F represent each of our 6 numbers. I'm asking about the first number, A. What is the first number? No. Nope. I don't know yet, but no. Nick? No. Gil? Not 2. Nope. Haley? Haley! Sneaky Haley. Dominique? No, but I like that. That was cheeky. First person was like, well, I'm not going to stick to the range of 0 to 42. I'm going to go higher and see what happens. No. But we'll play. Seth? Negative what? 10.4. Love it. No. Ashley? I love 42, but it's not 42. And Seth got really close. I had hope, and then he let me down. But you were there. You were there. You were there. I got Amanda. Amanda says 42 as well. Man, no. Oh, Madison, you came back. Excellent, Madison. What's A? What's the number? Sit first, then we talk. What's the number? No, what is the number? What is the first number in the series that will add up to 42? By the way, you got really close. You got as close as Seth got so far. A number? And did I get the tone? The inflection was good? Okay, so come on. What's the number? You got close again. What's the number? Good. No. Oh, you were so there. You were so there. No, Jordan, what's the number? Thank you. You cannot know. At this point in time, that number is undefinable. It is not knowable. You know what the sum is. Absolutely. You know how many variables or factors or levels go into that number. But that first number is undefinable at this point. You don't know what it is. It could be anything. It can be 10.4. It can be negative 47. It could be 47. It could be 2. It could be 1. It could be 0. You cannot know at this point. That is a free number. What's that? I don't know. We'll find out. Can tell you right now, A is free. In this series, A is free. That number is free. Now, where do you discover what that number is? When you measure it. When you actually measure it. When you do the work, you get that number. And I'm just going to tell you, just, coincidentally, it ended up being 23. That's what it is, because we measured it. Now I ask the next question. What is B? Jamie. Jamie, you were typing earlier. What's the number for B? B. Jamie says the perfect answer. I don't know. Why? Because it's free. Would be anything at all. Julie, you got married this past weekend. What number is it? You just tell me. You measured it. What? 29. I love it. Perfect. Love the logic too. So we measured 23. We measured 29. Those are measured. They are free until they're measured. Okay? What's the third number? It's free. We don't know. We don't know until we measure it. We measure it. It ends up being negative 10. These numbers are what we measured. I don't know. I didn't do the study. But we measured them. Victoria? What's the fourth number? It's, I don't know. It's free. We take the measurement. What did you get when you measured it? -5. So cool. What's the fifth number? I don't know. It's free. Each of these are free to vary relative to what the overall answer is. They're not defined or constrained by the overall answer. They are degrees of freedom. When we measure the fifth number, what did we measure? Catherine, what did we measure? You just tell me a number, it doesn't matter. 2. Lovely. We measured 5 of the 6 numbers in the series. 23 plus 29 minus 10 minus 5 plus 2. We know the sum is 42. Is the last number free? It is not free. What is that number that is constrained, that unfree number in this case? It's remember, I don't know what it is. Literally, you gotta tell me. Is it really 3? Just 3? Wow, that's cool. That is not free. In this example, the degree of freedom ends up being 5. Each test has its own basic structure for how this is accomplished, but the logic behind it is always the same bloody thing. The logic is you have a full distribution, and how many of the samples or how many of the categories or how many of the variables in those distributions are able to freely vary. But once you establish what each one of the factors or the variables or the data points in that distribution are, eventually you get to a point where they are not free anymore. That is a difference for your degree of freedom. It's why a lot of times degree of freedom in many of our cases is defined as n-1, where n is your sample size minus 1. In this case, that is not a free number. Once all its parameters are established, once everything is measured out, there is no solution but the answer there. That's the logic behind degree of freedom. Does that make sense? Everything good with that? Okay, I'm going to leave the 58.9 until Tuesday. Cool? I can't give you the homework tomorrow. So we'll figure that out later. You just got the one. You guys have a good weekend. Sean, did you leave me the pen?